has Slavic name, but he is coming from Portugal to speak about Swiss knives.
Dmitry Gorbunov is a deputy head of QA and QA automation lead who works at Dev Experts and has 12 plus years of experience.
His main field of experience is fintech projects. Dmitry has shared his knowledge at many conferences and meetups.
In his spare time, he writes electronic music.
Ladies and gentlemen, Dmitry Gorbunov! Welcome.
That was the best greeting in my life, actually. Thank you, guys. So, hello, everyone. You see my speech on the screen, but let's start with introducing myself. Guys did a great job of introducing me, but let me rephrase them. So yeah, hi, my name is Dmitry. You can call me Dima. I'm in IT industry for 15 years, more than 15 years actually, and 12 of them I've spent on Dev Experts, in different projects inside QA. During my career, I participated in numerous big testing projects within the fintech domain, primarily because Dev Experts specializes in fintech. And let me tell you, during these 12 years, I experienced a lot of last mile pain. The term I will describe you just a little bit later. So what we're going to talk today. First of all, I will describe you what the last mile pain is. Second, we will take a look on the approach, and then we will explore a few solutions, especially the solution I will be talking about. Okay, in order to understand what is the last mile pain, let's start with what actually test plan is, no matter automatic or manual, how it usually goes. So it all starts with a test plan, obviously, based on user requirements, the product, whatever. Test plan is composed into test suites, which are then decomposed to numerous checklists. Eventually, checklists are being converted into actual testing, no matter manual or automatic, it doesn't matter on this level of discussion. And after testing, we eventually get some reports, and reports are being aggregated into a sign-off, which best of us, I believe we have a lot of great people around there, the best of us are using the sign-off documentation, sign-off results, to fine-tune the test plans for the next iteration. And obviously, in 2022, if we take a look on each part of this cycle, there are numerous really great ways to implement any step. Like, we have a lot of frameworks, technological frameworks, process frameworks, and coding frameworks, which can help us do this stuff right. What are the typical challenges testers see in order to our experience, especially in the complex projects such as fintech? Let's start with one of the biggest ones. Test suites are almost always risk-based. What does it mean? Let me introduce you to the risk-based testing. I believe all of you know that, but if you don't happen to use it, let me go through it. Most probably, you already use it. The risk-based testing strategy is used to build effective testing strategy based on project scope, not all the scope you have. Basically, you only test something that has been directly changed into release, or you're adding something that was not exactly changed, but you want to test it because it's an important scenario for your system. As a result, this technique saves some money and time and allows you to do the testing faster in return of some kind of acceptable risk that you just admit and just try to, you just consider it to be low. What is important, especially in test automation, is that risk-based testing is applicable to test automation. Why is it important to have risk-based testing applied to automation? Let's take a look on one of the examples. We have for our trading systems. So let's just try to understand how trading looks like, testing of the trading, in the simplest example possible. So when we try to understand how to test trading algorithms, we are taking into consideration that we have to cover at least 4 order types, just market, limit, stop, and stop limit. We are testing 2 sides, because people can buy and sell, for example, stocks. We are testing 5 different types of executions. We are testing at least 8 instrument types, starting from basic ones like stocks, options, futures, and there are more advanced or less popular ones, such as ETFs or maybe different types of aggregations. We are testing that using 2 account types, cash and margin. And to actually test something, we have to test at least 8 actions. So we can place the order to buy something, we can update the order, we can reject it, we can fill it, we can make it working. So multiple actions. So if we calculate everything, then in order to get the exhaustive testing of only trading scenarios, we have to do more than 5,000 executions. Why is it important? Because if you try to apply this on automation testing, for example, UI testing, and if you are really, really positive, and if you are really, really sure about the reliability of your technology, if you put like 30 seconds on execution of one test case, because UI tests, they are quite fragile and slow, but if you are really optimistic, you put 30 seconds for each test case, and you put it into 10 threads, that gives you more than 4 hours of execution only for this pretty simplified trading subset. And that's not the worst. The worst is that out of these 5,000 tests, each failure has to be investigated and reproduced because you have to know why it failed. So as a result, this exhaustive testing practically creates more carbon than sense. That's obvious. So if we apply risk-based testing, so we only run something relevant for our release, we only test only critical parts, we get only meaningful failures. We have to accept some kind of risk because it's obvious that we can miss a bug if we don't test something. It contributes to manual work reduction because we do not test just everything we have. We are only testing something that is important for the functional team. And the worst part here is that practically it may turn your pipeline configurations into a nightmare. Why? Let's take a look. So if we are considering not trading, but maybe 4 different functional areas, in a trading system, this is also a very simplified example. So in a trading system, you can trade, you can look at some charts of the trading data, you can check your reports, how your trade were, and you can check some integrations with third parties like news. So if we assume that full scope of each of these functional area is big, right? But every patch of your release or every release, you are adjusting it in order to match it to the scope of release. So you select first slice of risk-based testing, second release you slice another type of slice, and then you slice again, and then you slice again. As a result, you will have, for only 4 releases, for only 4 functional areas, you will have to create at least 16 different executions with different parameters, different types of execution environment, different types of users, different types of prepared data, and so on and so forth. While in real life, I told you that example was really simplified. In real life, our functional areas are really up to 30. So we can have different types of trading, we can have different types of integrations, we have many, many types of testing that we have to convey in parallel. So if you take this into consideration, then you easily end up in 600 unique executions per release, and each of these executions has to have specific parameters that it will run with. And just to visualize that, that means that our test suites per release are split into several checklists, which are many-to-many result in absolutely random-sized testing batches. So as a result, we clearly understand that test cases we have in our test database are always many-to-many with physical executions and actual releases. And that means that we have to spend a lot of time and progressively more and more time on fine-tuning our pipelines, fine-tuning our execution, fine-tuning our strategies on how we allocate test resources and execution resources. Another example, it's pretty often when after execution, your results have to be post-processed. For example, your process or your client may require you to upload the results to test management system, or you have to provide baseline of the tests. I mean, the physical copy of the test cases you were testing against to the client as a part of deliverable, as a package. Or it's a little bit exotic example, but it is real. We have to synchronize our code base with the real test cases on the client side. So that means that we are just exporting the tests. Well, and if you take a look on these problems, you often see that no matter how good your frameworks are, and no matter how good, how perfect your tooling is, no matter custom, no matter commercial or open source, you end up creating a lot of last mile custom tools here and there and there. And we solve that. For example, for the problem of pipeline configuration, we are using test batching per each framework. Obviously, we have multiple frameworks for different types of tasks. So we created a separate CI connector per each framework. So each framework knows how to deal with the pipelines itself. And also, there are some challenges that we have fought against. That means the problem was that obviously frameworks will fight for resources because amount of machines that we can run on is limited, unfortunately. So frameworks that are running absolutely independently have to deal with each other in order to create some brotherhood between each other. So on the other hand, the problem of the exporting that I mentioned, we have solved it with test parsing using multiple leaps. We're using Java parser and library, for example, to actually parse the source code, and we can create test cases out of the source code. We are using TMS connector via API. For example, the simplest example here is Jira API, so we can create documentation in Jira directly from the code. And obviously, we have a matching engine between test entities. But here's the thing. When you work long enough, you start noticing patterns in these solutions, here and there, here and there. And as time goes forward and you have more projects in your portfolio, you start noticing that tooling is really repeats itself. So the problem, at some point, you realize the problem that you have to have a framework and have a solution or a way of thinking to properly design such custom solution and maintain them so it will not take that much of your time. So we decided that the test integration solutions can be unified, and we wrote a cool tool called Switchboard. You might ask absolutely legit question. Why do you need another tool to solve your tools problem? That would be fair. So here are some ideas that we thought of. First, we need a tool that will be highly configurable for our needs. It should be easily extendable and unified, so we can reuse it by changing the existing configuration. It should be in-house and portable, so we should not create another piece of code in a new repo, but we can reuse the existing solution. And last but definitely not least, we want to adopt to current practices and do not break them. That's important because, especially for the projects that we are not the source of, for example, if we have to help our clients with automation of the existing project, we have existed for a very long time, our main goal is to help them, not to interrupt them with our ideas or whatever. So, what is the model behind Switchboard? We thought about any integration of the testing tools as unified model that can do either test extraction, test processing, filtering, splitting, that means preparing tests for consumption by certain target, batching, that means moving tests into a desired mode, and last but not least, optimizing, because sometimes after batching you have to post-process your tests in order to remove duplication or save resources and execution time. So, given that model, we thought about our existing tools, how we can move them into a single solution. And it turns out really quickly that, for example, our existing Jira integration can extract data, can process it, can filter it, and split it. Our Java code integration can do only extraction and processing. Our TeamCity integration, and TeamCity is our continuous integration tool, we are able to do splitting, batching, and optimizing. And for Cucumber, which is our unloved small brother, we can do extraction, filtering, and splitting. So after analyzing that, we tried to build a solution, like a unified solution, and for every integration, we define it with the identifier components and parameters. And given the example of the risk-based execution that I started with, let's take a look on how it works. So I remember the idea here is that we have to take tests directly from Jira, not tests, but test scope, the JQL basically. We have to, based on this JQL, we have to select test cases from 3 different frameworks that we have to run, and then have to batch them properly to run into TeamCity, and then TeamCity will take care of the execution. So with the Switchboard unification, it's pretty simple. So we just set, in a unified model, we set all the integrations. So for example, Jira has extraction and filtering in this configuration. Java parser has consuming and processing features, and TeamCity is just a consumer. So what is important here is that we consider integration as an abstract entity that is available by just its features. And given that model, it's really easy to see how other tools that we already have match the same model of something moving into something. So yeah, a lot of different stuff that happens. So we define everything by XML configuration, and that sums up the overall idea that using Switchboard and existing integrations that we have already written for it, we can get any consumable source, process it by any set of pre- and post-processes, and then the result can be applied to any applicable targets, which are also supported by integrations. So the idea here is that in advanced systems, such as fintech, or I believe there are many systems out there that are also very complex, creating custom tools, you cannot avoid that. And Switchboard does not only provide some solutions that we have already developed, right? But it provides a unification framework that you can use to just optimize and save some time on designing the infrastructure of your integration. You can just pick maybe something that is already created and maybe write something small that you need, and then using this integration framework, you can use it in your own project. Some real life, so how we use it now. We have combined everything we did for other projects under Switchboard idea. So we are able to parse code, we are able to filter it, we are able to put it through our CI system. We try to not take control over CI system because it is good on its own. Then after testing has been completed, results are being collected, and we can use Switchboard to import the test data onto test management system. So what do we have as of today? We do have integrations with Cucumber. We can parse Java, and we can do a lot of things with Jira. We have integration with TeamCity. And I actually forgot that one of the latest things we have added to code parsing is we can parse Kotlin, and we can parse TypeScript. And there are some things yet to be done. We have room to improve. And things that we are working right now is some kind of a configuration manager, because as I said before, our configuration is managed by XML file. And again, in 2022, XML files are not our favorite way to configure anything, right? So we are working on even better Jira integration. That is important for us in scope of very complex data registering in Jira. And we are thinking about better packaging, because as you can imagine, we have many dependencies, and we want to be able to package safely and with respect to community and with respect to copyrights. So Switchboard as a tool is available today. You can get it on our GitHub. Yeah, basically, if you want to scan the code, I will stay here for a little bit. Yeah. So that was it about the Switchboard, a small handy tool which we are using now. I'm ready for your questions.
So, any questions? Any questions?
Hey. Hello. Странно. Any questions? Okay. Do you have any questions now, or you'll leave them for later when you find Mr. Gorbunov in the break?
In the rain? Outside?
Okay. Okay. No questions for now.
So please
Thank you, and
applaud.
please applaud Dmitry Gorbunov. Thank you very much.
Thank you.
You're very welcome.
And sorry, last but not least, we will have a special event a week after, right? Here in Sofia, where we will talk a little more about the tool. If you want to join us, please join. Thank you.
Thank you.
Thank you.
Thank you.
Uh-huh.